the size P of a small herbivore population, the size P of a small herbivore population at time t in years obeys the function P of t equals 700 e to the power 0.14 t if they have enough food and the predator population stays constant. After how many years will the population reach 2100? This is a very interesting problem. You're given an equation that models the behavior of the population against time. And then we're told that if they have enough food and the predator population stays constant. Now this is the area which we actually need. It says after how many years will the population reach 2100? After how many years? That is, at what time will the population reach 2100? So in other words, what that says is that, or what the statement says is that it says at what time. So it says find t, that is at what time, when the population is 2100, when P of t is 2100. So this is what you want to do. Now the model you're given is P of t equals 700 e to the power 0.14 t. This is the model that we're given. So all we need to do is, it says find t when P of t is 2100. So when P of t is 2100, so we make the substitution here. So it says when P of t is 2100, so you're going to have 2100 equals 700 e to the power 0.14 t. I could rewrite it this way by saying 700 e to the power 0.14 t equals 2100. So I've not changed anything. I just rewrote them by placing them the other way around. I laterally inversed the equation. So now our aim is to find t. So like we have gained, like the skills we have gained in the past videos, to find t, I need to remove all barriers around t so I can finally reach t. Now the first barrier I have is 700. How do I clear 700? By dividing both sides by 700. So I'm going to divide both sides by 700, and then this goes off. So 700 in 2100 is going to be 3. So what you have here is e to the power 0.14 t equals 3. So but then it doesn't stop here. Our aim is to find t. Now to find t, I need to bring it at the same level here. So like we have gained in the skills past, we're going to take the natural logarithm of both sides. So that's going to be the ln of e to the power 0.14 t equals the ln of 3. So when you take the natural logarithm, what you have here comes to this side like we know. So it's going to be 0.14 t, then the ln of e equals the ln of 3. So let me just show you something. So we know that the ln of e, so you know what the ln means. The ln actually means the natural logarithm of e. Now anytime you want to take the logarithm of a number that has the same base, then your answer is just going to be 1. So this is one of the laws of logarithm. So the log of a number that has the same base is always 1. Another example is if you have the log of 3 to the base 3 would also give you 1. You can try other examples on your own. So what we have here is the ln of e, which is the log of e to the base e. So this actually goes to 1. So what we are left with is 0.14 t equals the ln of 3. So let's just highlight this so we know this is what we want to find. Now to find t, I'm going to divide both sides by 0.14. So you divide by 0.14, you divide by 0.14. So this goes off. So your t is just going to be the ln of 3 divided by 0.14. And then I'm very sure your calculator should be with you. When you punch in the ln of 3 divided by 0.14, what you would obtain is going to be 7.847. You can confirm this answer, but since you already know how to use a calculator, just punch in the ln of 3 and then divide your answer by 0.14. You should obtain 7.847 years, since it says how many years. So the the unit is very important. So how many years? So just say, would say 7.847 years, approximately 7.847 years. Yeah, so that completes the problem.